Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This topic is usually reserved for the end of a trigonometry or college algebra or pre-calculus course. It's all about analytic geometry is what's really called, but really they focus in on conic sections. And there's a big stink about conic sections. People like, there's in the education community, a lot of people are like, oh, we cover conics and, you want to get to that end. But really, what are conics and why do we bother even learning about conics? So in general, conics are, they're literally intersections of a plane with the surface of a cone, a conic. So we're going to go ahead and take a look at these via an excellent app at intmath.com. Now here I am at intmath.com and via that web address. And you can see on your screen right here, there is a double inverted cone. And then there's a piece of paper that we would call a plane. And you can see that I can lift that plane up or move that plane down. I can also rotate that plane and make it flat. Let's see if I can do that perfectly. There we go. I can also move that plane left and right. Now, if you notice, the intersection between the plane and this cone is highlighted in this image here. And that current intersection, it's a section of a conic, which would be a conic section, is actually a circle. If you look top down, that intersection is a circle, and that piece of paper is a horizontal piece of paper, essentially, or that plane is horizontal. It creates a circle. So circles are a type of conic. They're a section that gets cut out from this intersection between a piece of paper and a cone. If we were to slightly rotate, oops, that's not the rotation. If I slightly rotate this, then looking at this top down, you could see that's no longer a circle. That's actually what we would call an ellipse. And it's more obvious if I really have a very steep kind of, steepness to the actual piece of, or the plane there. You can see a very oblong shape. That is an ellipse. And so it turns out not only are circles conic sections, but ellipses are sections of cones as well, or conic sections. And if I were to increase that angle until eventually it's not intersecting, it only intersects that cone in a single kind of weird shape like this, that shape right there is called, what you can see actually is off to the side there is still an ellipse. So let me make it a little bit different. There we go. I shifted it back a little bit and you can see there's a new shape in there, and that shape is actually a parabola. And if I were to tilt this even further to where that plane intersects the cone up above, you get this W shape, and that is called a hyperbola. So again, the basic three types of conic sections are what you see here, a hyperbola where the plane hits both the upper and the lower cone. And then if I tilt that plane back to where it's not hitting that upper cone again, well, technically it is. So let me see if I can get it back a little bit. And tilt it enough, you get a parabola, and you tilt it even more and you get an ellipse. And by the way, a circle is a type of ellipse. So really we only have three possibilities for what you get out of a conic section: an ellipse, a hyperbola, or a parabola. So let's go ahead and focus in on what all of these really are. As I mentioned, there are three types of conic sections. Ellipses are the kind of the circular oblong circle parts, And by the way, as I mentioned, a circle is actually just a certain type of ellipse. So ellipses contain circles, hyperbolas, and parabolas. And each of those are important in their own right. And when the plane passes through the cone's vertex, basically where those two cones meet, we get a point, a line, or a pair of intersecting lines. In these cases, we have what is called a degenerate conic. The problem with conics and why they have such a bad rap is there's a ton of definitions associated with conic sections. Words like eccentricity, vertex or vertices for plural, focus or foci for plural, major axis, minor axis, directrix. There's actually a bunch of others that I don't bother listing out here, but you have a bunch of definitions that kind of float around with conic sections. Now, I'm about to go on a diatribe about what conic sections are, and I want you to understand that my background in mathematics is both applied and pure, and I have to be very honest with you that conic sections aren't super duper prevalent in lower level mathematics. They do occur in calculus, and they can be very useful in differential equations, at least to build solutions to certain differential equations. And as far as calculus goes, it'd be Calc 1 for hyperbolic functions, and then Calc 3 for hyperbolic paraboloids and whatnot. But really, for the general STEM student, they're not that important. So if that's the case, why in the world do we study conics? Like, if they're always reserved for the back end of a textbook, and if they're always like rushed at the end of a course, why is that the case? Well, I'm going to read this and then I'm going to explain a little bit. All the conic sections have applications in the sciences. Ellipses are most notable for their use in astronomy because of the path that planetoids or planets travel, or asteroids or anything like that. Or maybe I shouldn't say asteroids, but planets at least. Parabolas and hyperbolas are used in optics. Additionally, hyperbolic structures are used as cooling towers for nuclear reactors. That's why you see, like, whenever you see a nuclear reactor, it has that kind of shape to it. It's hyperbolic paraboloid, or hyperboloid actually. Knowing the forms of the conics is especially important in calculus. They help build the hyperbolic functions in differential calculus, and as such are important in the solution of differential equations. However, I'd be lying if I were to say that all of the definitions encountered in most math texts prior to calculus will ever be seen again by the vast majority of STEM students. I conjecture that this is the reason most, if not all, textbooks at the pre-calculus level and college algebra level treat conics as a final peripheral topic. They end up being an afterthought. And I gotta tell you, I have done research when I was going through my doctoral program in supernova expansions and modeling flame fronts of supernovas and dealing with astronomy and astrophysics. And even then, I barely even needed any information about the conic sections. Now, I'm not saying this. I know some mathematicians might watch this and they might say, well, you shouldn't tear down conic sections. And I'm not tearing down conic sections, but I definitely think that to say that they are the end all be all and they're the last topic in a course because they're so important is not true. However, they're sort of like, if you've taken trigonometry or you're in a trig course, they're sort of like the sum to product and product to sum formulas that you would encounter in trig. There's 8 of those formulas. Nobody has you memorize them. It's just important enough that you know they exist. Same thing with the equations of conics. It's important enough to know they exist, and it's important enough to know their forms. Really, that's pretty much it. So if you're going to watch the rest of my video series on conic sections, I'm just going to let you know it's very superficial, not because I'm in a hurry, but because it's just not super duper important for the next set of courses you're going into. Yes, you do need to know the structures of an ellipse. You do need to know how to work with shifted conics. You do need to know how to work with hyperbolas. You don't honestly need to know all the other peripheral activities about or information about parabolas, which are like directrix and all that other fun stuff. While that's cool theoretically, it is actually not very helpful for anything you're going to learn in the future. So yes, this is a long-winded way of me saying I don't personally find conics that attractive. There are some great applications, but as far as teaching them, they're really, really just terrible to teach because you're usually at the end of a course and trying to rush your way through. The students feel terrible, and really the instructors do a crappy job going through. I'm not saying instructors are terrible because I'm an instructor. I'm a professor of mathematics, but I'm saying that ask any of your math professors, they're rushing to get through this topic because it's the end of the course, and that's kind of sucky. So why even kind of talk about it, or why spend time on the theory of it? Why not just deliver the content that you're going to need as a student? So that's what my videos from this point forward, at least in the Conic sections series, are going to be. Just an information delivery platform. I am going to prove a couple things just because I like to, but other than that, I'm not going to spend a lot of time talking them up and saying they're great because they're so-so. So thank you for listening to my diatribe here and watching this video. And in the next video, I will sadly start into ellipses.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.